Hello everyone. In this video, we will learn about the basics of correlation and regression in R. To start off, let me share my screen and open R Studio. So as before, we will open a new file and go to an R script. Now in this R script, let me first load our dataset in R. R has a number of loaded datasets. So for this correlation and regression, we will work on the IDs dataset. So IDs dataset consists of the specification of the types of flowers. So to load that, we can simply type or simply use a function data IDs. So in quotes, if you write data IDs, this will load the dataset for you. To check whether you have done this correctly or not, you can check the head of that. So from the head, you can see it has some of the variables like sepal length, sepal width, the petal length, petal width, and the species. What kind of species the flowers are. Let us check the dimension of this. How many rows and how many columns are in this data set? So there are 150 rows. So the records, there are 150 records in the data set, and it is been recorded based on 5 columns. Now, let us make a correlation. Let us first of all, let us do a scatter plot. So as you are aware, the scatter plots needs to be done on 2 quantitative variables. So first, let me do a scatter plot. Now, for this example, I am interested in the petal length and the petal width. So, and from the petal length, the petal width, and let me choose my X and Y. So for my X, I will choose the petal length to be my X. So let me rename a variable called as petal underscores length. Petal underscores length is the variable named as petal length, that is iris dollar petal length. So this is easier for me to do the correlation with this way, so that I don't have to always write iris dollar. That's why I'm doing a shortcut over here. I'm renaming these variables, and let me have my Y. Let me rename my variable Y as petal underscores width. So that is iris dollar petal width. So I did this. You can omit this part, but I'm doing it so that I don't have to always write iris dollar. To omit that part, I'm doing this petal length and the petal width. Now, first thing, we will be making a scatter plot. To make a scatter plot, we can simply type in plot in your X and a Y variable. So the X variable is petal underscores length, and the Y variable is your petal underscores width. If you hit enter, in the plot, you can see the petal length and the petal width. So over here, it seems like there is some kind of a linear association. If I zoom this out, it seems like there is some kind of a linear association. So yes, there might be some kind of a correlation. So we can argue, okay, from the scatter plot, it seems like there is some sort of linear association between them. Now let's check this correlation, if there is some correlation or not. To check the correlation, so next we will be looking at the correlation coefficient. To check that, we will be using the function COR. So the correlation function chooses for X and Y. Now there are various methods to do that. We have the Pearson method, the Kendall method, and the Spearman method. So we will refer to the Pearson method for this case. That is by default, which has been given to us. So over here we have your X and Y. So the X variable is petal length, and the Y is your petal width. This will give you the correlation coefficient. So we have a very high correlation coefficient. So over here we have a value of 0.9628. So we have a very high correlation coefficient. This implies that 96% of the variation in the petal width can be defined by the petal length. So one can be defined by the other. So we have a very high correlation coefficient. Now, once we know that we have very high correlation coefficient, we can now next move to the simple linear regression. The simple linear regression. Simple linear regression uses only one x variable. For multiple regression, we can have multiple x variables. So there can be your x1, x2, x3. That is, there might be more than one independent variable. However, for simple linear regression, there is only one independent variable. So to do this, first let me do a linear model, least square linear model. So let me define that as model which is equal to LM. The function that we use is the LM function, and we have our y, and the formula is y tilde x. So y for this case is our petal width. Then we have the small tilde or the simulation sim function that we also use, and we have the petal length. So this is a simple linear regression. Now, what does this imply? What is your p0? Because if you have a simple linear regression, you are mostly interested in the p-value, that is whether the regression is significant or not. You're interested in the coefficients, that is b0 value, the b1 value, and the adjusted p-square. So how to get that? To get that, we can simply write a summary model. So if you use a summary function, it gives you all this information. So over here we have this coefficients, that is the intercept, that's negative 0.36. So this is the value of your b0. The petal length is 0.4157. This is the value of your b1. Now we have an adjust r squared to be 0.9266. That implies 93% of the variation can be explained. And we have a p-value which is very, very small. So this implies that this regression model is significant enough. So how does this regression model? So what does this regression model looks like? So the regression model over here will be, so the regression model is your petal width. So petal width, this is equal to the value of a b0. If I round this to 4 decimal points, so this should be negative 0.3631 plus 0.4158 times the petal length. So this is your regression equation, regression model or regression equation. So this is your regression, simple linear regression equation. Okay, so once we have the simple linear regression, we need to do a few checks. First, we need to check whether the residual plot is scattered all over the place. We know we have a very high R square. The p-value is significant. We also need to check whether the scattered plot, the residual plot, is scattered all over the place. That is, it is no pattern. To check that, first what we need to do is we need to find the residuals. So we need to get the residuals. To get the residuals, let me rename this as RES. We use the function RESID, the receipt function, receipt of the model that we have found. So RES will give the receipt function, will give you the residuals. Now we can produce a plot of the residuals versus the plot fitted model. So we will have a plot of residuals versus fitted. So we have the residual plots and we have the fitted plot. To do that, we can simply type plot, and we have the fitted. We will use the fitted function of the model. So this goes in your x, and the y is your residuals that you have found out, that is using this RES. So using the residual function what you have found, if you simply plug in your y, you will get a plot. So this is how the plot looks like. Now you can also add a horizontal line at 0. To add a horizontal line at 0, that we can simply use a function of AB line of 0 and 0. And if you do that, it will pass a straight line, a 0, 0 line, a horizontal line at the 0, 0, 0. So it seems like it is scattered mostly all over the place. So there is no pattern over here. So we can say that the regression model is a good fit over here. So again, to do this, first find the residuals and plot that against the fitted model. So plot in your X, it goes a fitted model. In your Y, it goes as a residuals. Now, also, since we have this regression model, we can also do some kind of prediction. So we can make some prediction. So let me see, let me predict the value of your petal width. So predict what is the value of the petal width when the value of your petal length is 3. How to do that? To do that, we can use a predict function. So the predict function in R gives you the prediction of the petal length. Sorry, gives you the prediction of the petal width when the value of the petal length is 3. So predict. Now we are predicting on the model that we have created, that is a regression model. Predict model, and since we are just inputting a single value, so we will be using this data frame. So we will input this value of the petal length equals to 3 under this data frame. So this should be equal to petal underscore length. This is equal to 3. So if you simply write petal length equals to 3, it will give you for all the values, but we are just we only want for just one value of 3. So it's better to write it under the data frame. So predict model, comma, data dot frame petal length equals to 3. And if you hit enter, this gives you the value of the petal width when the value of the petal length is 3. One more thing that you can do is multiple regression. So instead of having just one X or one independent variable, over here we can have more than one independent variable. So we can also do with the sepal length and the sepal width. So just like before, let me write sepal underscore length. Let me redefine. So sepal length is equals to iris dollar sepal length. And let me redefine another variable, that is sepal underscore width, which is iris dollar sepal width. So let me redefine those variables and round them. Now to do a multiple regression, let me do another model, that is model 2, and I will be again using the same function a log n. So I can do ln. Now my y variable is still the same, so I am still interested in knowing the petal width. So the y remains the same, petal width, this, and again we have this tilde because y is, there is only one y variable, so the petal width is still as it is. So I am trying to regress y on different independent variables. What are my independent variables over here? The independent variables, so the first one is the petal length. To that I want to add the sepal length, and also I want to add the sepal width. Let me run this. Seems like it has worked out. Now let me see the summary of this, because if you use a summary function, because I'm writing summary of the model too, because right now I'm interested in the multiple regression. So if I do summary of model 2, this will be giving me all the coefficients, that is the value of B0, B1, B2, and B3. So the intercept value is negative 0.24. The value of a B0, B1 is 0.52, value of B1 is 0.21, the value of a B3 is 0.2283. Most importantly, the value of adjusted R squared is 0.9366. So this is highly significant, a very high value of R squared. And also the P value is very, very small. So since the p-value is also is very small and we have a high value of r squared, we can say that this regression model is perfect to predict the petal width. Now, how can we write this regression equation? So if you want to write this regression equation, so this regression equation can be written as petal width, and if I round everything to 2 decimal points, so this should be equal to negative 0.24. This is your intercept plus 0.52 times the petal length minus negative 0.21 times the sepal length plus 0.23 times the sepal width. Let me write this in a different line so that it's easier for you to understand. So we have plus 0.23 times sepal width. So this is the multiple regression, and again over here you can check for the residuals as well. If you want to predict for more than one x variable, you can also do that. So you can do the same thing as you did for simple linear regression. In multiple linear regression, the only thing is we have more than one independent variable. So in today's video, we discussed about scatter plot, the correlation coefficient, simple linear regression, finding the residuals, the residual plot, finding the value of adjacent r square, finding the p-value, and lastly, we did the same thing, discuss the same things for multiple linear regression. Okay, so that's all I have for today. Thank you for watching.